Today we're going to be creating a CLI calculator with Typescript. So to get started, first thing you need to do if you don't already have it installed, install Node. Go to nodejs.org and click the green button to install. It's like a wizard installer. It'll prompt you through the installation for that. Once you have Node installed, you can go to this link here, and we're going to use this npm install -g for global Typescript, and we're going to use that in our VS Code. So make a folder. I called mine calc Typescript. You can call yours whatever you'd like, and we're going to run npm i-g Typescript. I'm not going to hit enter on that because it's going to take a little while to load, but you go ahead and do that. Hit enter and let Typescript load onto your computer. Then you might need to kill the terminal, so I'm going to do that with you and restart the terminal, start a new terminal. And then from there, we're going to check the version number of Typescript to make sure it's installed. So to do that, we're going to do tsc-v. And here on mine, it's version 3.8.3. It may be newer on yours. All right, now that we have Typescript installed, we can initialize our project. So down in the terminal here, we can do npm init-y and let that set up, and we should get a package.json. There it is. Okay, and we can go ahead and create an index.ts file. The ts extension is Typescript. And then inside of here, we're going to do, just to make sure it compiles, something like console.log. I am writing Typescript. And semicolon. Save it. Now down in our terminal, we're going to compile it to JavaScript. All Typescript files compile to JavaScript. So to do that, we can do tsc. And then the name of our Typescript file, index.ts. And we're going to hit enter. And you're going to notice over here a node file is going to appear on the left once it compiles. Yep, there it is. Okay, and it's the same. There's no difference between Typescript and JavaScript for console.logging something. As we get more complex, you'll see there's a difference between the two, right? Okay, so we have a compiled index.js file. Now we can run that in Node just like we would any index.js file. So node index.js, and we get the result put out. Okay, I'm pointing at it, but that doesn't really work, does it? There we go. I am writing Typescript. All right, so that's initially kind of how we get Typescript to work. Now we need to figure out how to get user input, right? Because this is a command line application, and we need to get input from the user. In JavaScript, which is pretty much Typescript, right? But Typescript has types. In JavaScript, the normal asynchronous way of getting user input is kind of a pain. So we're going to install a synchronous library to do that. And the library we're going to use is called Reline Sync. You don't have to read through all this here that we're looking at, but I just wanted to show you kind of the thing we're going to be using, which is this question functionality. So we can say readline sync.question, and then we ask the question, and it stores the answer inside of, or it stores whatever the user inputs inside of inside of a variable, and that's definitely what we're looking for. So to install this readline sync, going to go into our file here, and we're going to do npm i-save readline-sync. Going to let that install, and while it's installing, let's talk about one more thing we need. We're using Typescript. This readline sync library has types that we're going to use with it to be able to add types to this readline sync library. And to do that, for a lot of JavaScript libraries, there's an attached types library, and in this case, it's this line right here, at types/readline sync. So we also need to install the types for readline sync. So back to the terminal, npm i-save, I is just short for install, at types-readline-sync. Let that install, and then we will have everything we need to make our calculator project. All right, now we have everything we need to get started building our calculator project, right? So at the top of our .ts file, we want to import the readline sync library that we just installed. And in TypeScript, we can use the import syntax instead of const readline sync equals require readline sync, we can do import, and we only want the question method, so we'll destructure it right here on the left side. Import question from readline sync, and that's all we need to do to get the question method, and we want to make sure that works. And to do that, let's create a function called main, and inside of main, a lot of times you'll see brackets like this, but when I'm using TypeScript, I like to put the brackets down here. I think it's just more clear to me. But inside of main, we're going to make sure this question works, right? So we can do console.log question and then run the main function down at the bottom. Now you'll notice there's no types yet. That's fine. Let's save it. We're going to do tsc index.ts. And if you push the up arrow, you can get previous commands from the terminal. So I can do this and find node index.js. Once it compiles to the index file, which it did here, right? You can now see this is totally different than it was before. Every time we run that tsc index.ts file or command, it compiles into this JS file. All right. So now we run the JS file, and we're going to see that this question method is a function, which is perfect. That's exactly what we want, right? Now we can test that functionality. Also, our first type we're going to use here is this main function. It's not going to return anything. So to say a function is not going to return anything in TypeScript, we're going to do a colon, which looks a little funny, but it works, and void. And void means, hey, this function is not going to return anything. If you're doing like addition, maybe you have a function that returns a number, in which case you would put number here or something like that. But as you can see right now, if I put number, it's throwing an error and saying, hey, a function whose declared type is neither void nor any must return a value. And this function is just logging something. It's not, so we just need void. All right, and now that we know we've imported our question, we got main working, and we wrote our first type, we can get some input from the user. So const, because if I'm not changing a variable, if I don't want the variable to change in TypeScript, I'm going to use const, or in JavaScript, same thing. If it does change, I'll use let, right? So const first string, everything comes in as a string. Those types we imported, this question method always returns a string into the variable, no matter what it is. So I'm going to call it first string, even though we hopefully will be getting a number. And this is where we can say, hey, this first string is going to be a string, equals question, the question method from above, enter first num. Now we know, or number, we know it's a string, but the user doesn't when they enter it. So we just tell the user to enter a number. If we say enter first string, they'll be very confused. And I'm going to add a new line on the end of that. Question does not automatically add a new line. So there we go. And let's make sure that works. Console.log first string. Save it. We're going to compile it to Node. And then run the Node file. Enter first number, 44. And it prints out 44. Great. That's exactly what we wanted. All right, now we also need an operator and a second number, because our calculator is going to take a first number, operator, second number, and then do the math based on the operator, right? So const operator, there we go, is also going to be a string, and question, enter operator, oops, with a new line. And the last one, second string, is also a string. Everything's a string when it gets returned from the question method. Enter second number. And we'll also give that a new line. Okay. Now we have our first string, operator, second string. Let's make sure that works. Console.log, first string, operator, second string. Save it, compile it, and run it. Enter first number, sure, 22 plus 11. All right, and we log what we expect to log. Now, if you remember from JavaScript, when you add a string to a number or a string to a string, you're going to get a concatenation of those things. So if you add 22 and 11, you're going to get 2,211 instead of, as a string, instead of 33, right? So we need to convert these strings that they entered into numbers. And we actually want to make sure they're numbers before we try and convert them, because we're going to end up with an ugly not a number error if we don't do that. So that's next. Right, so before we can add all these together, or before we can do the operations on these numbers, or string numbers, we need to make sure that they're indeed valid inputs, right? We need the first string to be a number. We need the operator to be plus, minus, add or subtract. It can't be cat or dog. The user could input anything, and we want to guard against that. And the second string, or the second input, also has to be a number, right? So let's verify that. So we're going to create first a function called isNumber to be able to check if the first and second strings are a number. So we can do function isNumber, and isNumber is going to take in this first string and then the second string individually. So it's just going to take in one at a time and check them. So I'm going to call the variable string, str, short for string, and then I'm going to say, hey, this takes in this variable, and it is of type string. And it's going to return a Boolean value. It's going to say, hey, is this a number or not? Is it true or false? Is it a number? So we're going to type Boolean out here. Takes in this variable of type string and returns some type of Boolean. And to check if something's a number, if it's a string, here's how we're going to do it. Const, and I'm going to call it maybe num, because it might be a number, equals parse int string. And parse int, there's a reason I'm not using, you could also use number around string, but that provides a slightly different functionality from parse int. Parse int's actually easier to verify and check. That's just my opinion on that. So parse int string, and it's going to parse it, and it's either going to return not a number or the actual number, right? So then we're going to do const isNum, and isNum is going to be a Boolean, and I'm actually going to explicitly type that. I've went back and forth on that, but I think it's more readable to add Boolean there, and it's going to say is not a number, maybe num. All right, and we'll talk about what's going on here. And then let's return it first. So return isNum. So this is how we check if something's a number in JavaScript, TypeScript, or one way to do it. So we parse this, and this is either going to parse to, let's say, like 33 or not a number. It's going to be either a number or not a number. To check if something is not a number in JavaScript, you have to use this isNotANumber function. And isNotANumber, whatever you put in there, if it's not a number, it will return true. If it is a number, it'll return false. So that's that. And then this, I actually don't like this operator. Let's make this more explicit, more clear, and say Boolean. This is another way to write the bang operator, to invert the true to false or false to true. I prefer this. It's more explicit, using Boolean instead of the bang operator. So is 33, if we parse it, and 33, and it becomes 33. So 33 inside of is not a number. 33 is not a number is false. But we want if it is a number, so we use Boolean and flip it to true, so it is a number. Not a number goes in. Is not a number not a number? That's true. And then we flip it to false because we want to know if it is a number. It's a little confusing, but that's how it's done. Or that's how I did it anyways. Okay, so let's test that functionality, right? So we can do const, and we're going to say first num, and it's going to hopefully be, well, we'll just say first num equals is number, and we're going to pass in the first string, and then we're going to console.log first num. Save it. Going to compile it. Run it. All right, so our first number, we'll start with 44 plus 11. False. Uh-oh, that's bad. 44 is a number. Maybe we do need the bang operator here. I'm just trying this out. Yeah, okay. So it turns out Boolean won't work on this. We actually do need the bang operator. I prefer Boolean when I can, but we'll use the bang operator, and that just flips the Boolean value. So is not a number, maybe num, 44 would return false, and then we want to flip that to say, hey, that is a number. But is not a number is the only way to check if something's not a number in JavaScript, so that's why it's confusing. Okay, now that we have that, we need to be able to check if the operator is an operator, so that's next. All right, so now we want to check if something is an operator, if this is an operator. We want to make sure it's valid, so function is operator. And of course, it's going to take in an operator of type string, well, the operator variable, and operator variable is type string, and it's going to return again a Boolean value. Is this or is this not an operator, right? And right now, why is it giving me that error? Okay, because it's not returning anything yet. So this will give an error until we return something. That's something nice about TypeScript, is it lets you know if something's messed up before you compile it and run it and find the error, the silent error, right? So now we can do, we need to check if it's plus, minus, multiply, or divide. And to do that, I'm using a switch statement. I'm sure there's other ways to do this. It's just the way that worked for me, and I thought looked really clean. So I'm running a switch on the operator, and if it is plus, okay, if it's also minus, or multiply, or divide, then I want to return true. And you could also make this a Boolean statement, or right? So you could say return operator triple equals plus, or operator triple equals minus, or multiply or divide. I just think the switch case looks smoother to me, so that's the way I'm doing it. And underneath default would be return false. All right, and let's test this up here and make sure this works. So we're going to say op for operator, and we're going to use the isOperator function we just wrote. And that's going to take in our operator, and we're going to console.log op. Make sure that works. Okay, so we compile it to Node, to JavaScript, and then we run the JavaScript file. So let's say 33 plus 22. All right, that's true. Now let's run it again, and let's add an invalid thing. So 44 cat 11. All right, and false, right? So cat's not valid. It has to be one of these things. All right. Now that we have our validity checks, we can go up here and we can check, make sure everything is valid in one single statement. So we can do const valid input. So we're going to make sure everything's valid. And that valid input is going to be a Boolean. And you don't have to specify it's going to be a Boolean. TypeScript can infer that. But I think for readability right now, I'm going to leave it. And it's going to be a Boolean. And equals is number. And we've already written that function, right? First string. Want to check if the first string is a number, and the operator is an operator, and that the second string is a number. Now, if I was to try and put in like 33 here, you're going to see that this throws an error, and that's because is number has to take in a string, and we're trying to feed it a number or an integer. And it's like, no, you can't do that. So that's what's happening there. So it has to be of type string, and we know we want second string there. Okay, so, and then we can log if all the inputs are valid. So console.log valid input. Save. Again, compile. And we can, there's ways to shorten this process of having to do both manually, but works for us for now. So 33, let's say fish, 11. All right, and it's false, it's not valid. Let's try something else. Dog plus 22. False, it's not valid. Let's try the other invalid one, right? 33 minus cat. False. All right, now let's try a valid one. 101 divided by 33. True. Okay. So this valid input only returns true if all the user inputs are indeed valid, which is what we want. So underneath there, we can now say if valid input, right? If the input's valid, then we want to run our calculate function. So to do that, we still have strings, right? We parse them in the isNumber function, but they're not available here. So we need to parse them up here. So we can say const first num, and it's going to be a number, and parse int, not parse float, parse int, first string. Maybe we want to parse it as float. I guess it doesn't matter for now. Const second. We can change it if we need to then. Second num is a number. Parse int second string. And then we want to get the result. So const result equals, and we're going to use calculate here. Calculate. We don't have this function yet, so we're going to have to write it. And it's going to take in the first num, the operator from above, and the second num. If it's not valid, right, else. If it's not valid input, we want to console.log, and we, just to make the formatting nice, I'm going to add some new lines here. Invalid input / new line. And then we're going to rerun this main function until we get a valid input. So if we run this, we actually, let's do this for now. Console.log is valid. So we run the main function. If the input's not valid, then we say, hey, that's not a valid input, and we start over, and we have them input stuff again until we get a valid input. Then we do the calculation. So make sure it works. We'll get to the calculate function in just a second. Yeah. So 33 cat 11 invalid input. So do it again. 11 plus 20. Oops, 22. All right. So now it is valid and it shuts the program. Perfect. Okay. So uncomment these out. And now we need to create this calculate function. Another thing to note is this operator. Once we know it's valid, we know it can only be 4 things, right? It can only be either plus, minus, times, or divide. So it not only could just be a string is very broad for this now. So initially when they put it in, it had to be a string. They could have put in anything, but now we know going into this calculate function, this operator is indeed an operator, and it can only be one of those. So we can actually limit that option. We can kind of limit that as a type in itself. So we can, up here, we can do type operator equals plus minus. We're using these kind of pipe symbols here, times, or divide, and that's it. That's the only thing of an operator. We just made our own type, and that operator type can only be one of these things. Now to use that here, you'll see in a second, we need to specify. So underneath, we need to make this calculate function calculate, and we know that first num is now a number, so we can do let's say first num, and it's a number. Operator was initially a string, right? And second num is a number. And then we can write this function out. You'll see there's no complaints here. Oops, let's do that. There's no complaints about operator being a string, because it is a string. It could be anything, but we want to make it more precise than that, and that's where this comes in. So we could say operator is going to be of type operator, and you're going to see Typescript doesn't like this. Maybe it does here. No, it doesn't. Up here, it's saying, hey, argument of type string is not assignable to a parameter of type operator. But we know that this is only one of these 4 things if it makes it to this point in the code. So we can say, hey, TypeScript, we know a little more than you about this particular variable. And we can say operator as operator. So we're explicitly saying this operator is going to be of type operator when it's passed into this function. And that allows us to write a cleaner switch statement down here and calculate. And now you'll see there's no complaint here. We're overriding TypeScript's complaint, and we're saying, hey, we know that this will be plus, minus, multiply, or divide. So down in calculate here, now we can write out our function. And because we're passing an operator, when we run a switch statement, we don't need a default value because there's only 4 possible values. And if it's not any of those 4, and that's literally all it can be because an operator is only 4 values. If it were a string, you'd need to have a default and throw an error or something like that or rerun main. But because we made it a type operator, we don't need to do that, which is, I think, really cool. So switch on the operator, not the operator. There we go. And inside we're going to have a case of plus. If the operator's plus, then we're going to return first num plus second num. Okay, and you're going to see the pattern here, right? Minus, return first num minus second num. Case multiply, return first num times second num. And lastly, divide, going to return first num divided by second num. All right, and that's it. We don't need a default. Usually in a switch statement, you need a default case, but in this particular instance, we don't because this operator function here, or this operator type, excuse me, it's saying, hey, this can only be one of these 4 things, so you only need to account for one of these 4 things, which I think really cleans it up and makes it look super nice. So that's it. That should work. I guess we need to log the result, right? Console.log result. I think we have our full CLI calculator here, so let's make sure it works. Make sure we don't have any bugs. Compile the TypeScript into JavaScript, and then run it. Okay, so 33, I'm going to say first, it's fine. 11, we know that's invalid. It says invalid input. Great, right? It went down to this else statement, and it's rerunning it. Say cat plus dog. Okay, it says invalid input, not going to work. So what if I do 44 divided by 3? All right, I get a number returned, right, which is exactly what I want. We can run it again with different numbers. Let's say 3 times 33, get 99. Yeah, so that's it. We've made a command line calculator with TypeScript. Hope you enjoyed this introduction to TypeScript and maybe your first TypeScript project. If you did, please like the video, subscribe, and we'll see you soon. Thanks. Bye.